Now we discuss about the homogeneous functions. U is equal f of xy is a homogeneous function of degree n. If f of tx dy that can be written as t raised to n f of xy. That means x is replaced by tx and y is replaced by dy. And if you suppose to get t raised to n as a common quantity and into f of xy that can be represented, and then only we can say that the given function is homogeneous. Otherwise it will be non-homogeneous. Here we can say that this is the homogeneous function of degree n. For example, f of xy is there, x cube plus y cube divided by x plus y. So what we are going to do, x is replaced by tx, y is replaced by dy. And when we simplify and when we take common from the numerator as well denominator from the all the terms, not only two terms except the one terms. Only we are going to concentrate each and every terms whatever we have. So we get the t square into x raised to cube plus y cube divided by x plus y. So whenever we see, so this is what exactly our function. So at t square into f of xy. So definitely we can compare with this. So this is the homogeneous function of a degree n is equal to. Suppose we have given that another function like that. F of xy is equal x square plus y square plus 1. So can we say that this is a homogeneous function? So if I replace x is equal to tx, y is replaced by dy, so tx whole square plus dy whole square plus 1. But from this we can take t square, but from this it is not. That means it cannot be expressed like that. And therefore we can say this is not a homogeneous function of degree 2. Okay, so now let us see Euler's theorem. If u is equal to f of xy is a homogeneous function of degree n, then x times del u by del x plus y times del u by del y is equal n times u. And that is you can prove. But we are not going to prove in details. But here, second order part is there. If u is equal to f of xy in a homogeneous function of degree n, then x square into del square u divided by del x square plus 2 times xy del square u divided by del x dy plus y square del square u divided by del y square is equal to n times n minus 1 u, where n is nothing but degree of the homogeneous function. So if to consider simple question, but this theorem, first I just recall you, this theorem is applicable if and only if the homogeneous function is there. If it is not homogeneous, then we cannot say about this one is equal same like that is n into u. So we will always keep in mind that x into del u by del x, so u itself must be homogeneous. So let us look at the question number 1. U is equal to x cube y square sine inverse y by x. Then prove that both the terms, and this is 5 times u and this is 20 times. So is this function is homogeneous or not, and how it is? But we know that this is what exactly n into u. So we know that our answer should be n is equal to 5. And again, what it should be? N into n minus 1 into u. So n is equal to 5 is there. So 5 into 5 minus 1, that is going to be 4. That means this will be whole. So our target is to what? We need to simplify that is the function is homogeneous or not. If it is done, then we are done with the solution. Is that okay? So let us say u is equal to this one. So first we verify x is the function is homogeneous or not. So just take x is equal to tx, y is equal to dy. So whenever you see, so t will be cancelled out. So this is the same. And t raised to 5 is there. But this is what exactly? Our u of xy. So t raised to 5 into u of xy. So we are getting that this is the homogeneous function of degree 4. It is n is equal to 5. So therefore by Euler's theorem, we get x into del u by del x, but this is the homogeneous, and that is we always keep in mind that, because when we look at the Euler's modifier theorem, so it will be a little bit different. That's why I'm just remind this one, plus y into del u by del y is equal n times u, but n is nothing but 5. This is the second order, and again x square into del square u by del x square plus 2xy del square u divided by del x del y plus y square into del square u divided by del y square is equal n into n minus 1 u. But n is equal to 5, and when you simplify, you will get this one. Now let us look at the modified Euler theorem. If u is equal f of v and v is a homogeneous function, that means u itself is not directly homogeneous function. But when we modify it and then if it is homogeneous function, and then we can apply the Euler's modified theorem. So x times del u by del x plus y times del u by del y is equal n times fu divided by f raised u. And that is the again good theorem to determine its partial derivative, as well as second order is that. But whenever you assume that u is equal f of u, so v should be homogeneous function of degree n, not u itself, not f of v. That is we will keep in mind. So second order is that, so g of u into z dash u minus 1, but g of u is what? This one is the g of u. So where g of u is equal n into f of u divided by f raised u. So let us see an example. So u is equal to 10 inverse. But how we can say that which one theorem we have to apply? A homogeneous theorem or modified Euler theorem. So for that, first we will keep in mind that first we observe that u is there, again u is there, u is there, u is there, again u is there. That means first, is the u is the directly homogeneous function? If yes, then just go through the theorem 1, that is the homogeneous theorem. If it is not directly, then we have to use the modified Euler's theorem. So for this question, first we can clearly see that this is not directly homogeneous function, because when you replace x by tx and y is equal to y, so whenever you replace simplify, so you will get like that 10 inverse t square into x square plus y square divided by only x minus y. But it doesn't mean that t square into u of xy. That means it is not a directly homogeneous function. So we have to modify it so that whatever x square plus y square divided by x minus v will be the homogeneous. So for that, it is clear that I have to multiply 10. That means I just take 10 on the left hand side. I'm just going to get 10u divided by x square plus y cube, x cube plus y cube divided by x minus y. So now it is clear that I say this is v of xy, and that is what exactly homogeneous function of degree 3, because whenever you simplify, so you will get the n is equal, that is 2. So now f of u is equal, that is 10. Just try to understand whatever we have represented in the statement. We have taken that u is equal f of v and v is a homogeneous. This directly this function is not, only v is the homogeneous function. So now we are just gone through that 10 x cube plus y cube divided by x minus v is the homogeneous. That means we are able to apply the Euler's modified theorem and f of u. So f of u, whatever it is, and that is going to be what? Exactly our function. Here if I say 10u. And this function itself is what? Exactly homogeneous function of degree 2. And therefore, x into fu divided by f del u by divided by del x plus y into del u by del y is equal n times f of u divided by f raised u. And according to this formula, n is equal, that is 2, and f of u is nothing but 10, its derivative is x square u. And whenever we will simplify, so we will get 2 times sin u into cos u, and that is sin 2u. But our second order is that x square del square u divided by del x square. In other words, you can write x square uxx plus 2xy u sub xy plus y square u sub yy. And that is u of u into z dash u minus 1. But we need to replace g of u is equal whatever we have determined, that is the sin to u. And if I suppose to replace it, so I will get this one. But again, we know that this is, as when we apply this sign to inside, so we will get this one. And 2sc is that. 2sc is what? Exactly c plus s plus s. And sin alpha plus beta and sin alpha minus beta. And you will get sin 4u minus sin 2u. Otherwise, you may say that the 2 sin alpha into cos alpha, and that is what? Exactly sin 2 alpha. because theta is nothing but same. So you may apply this one directly, otherwise you have this one formula and you will get the sine 4u minus sine 2u. And whenever you apply the another formula, that is the s minus s is there exactly 2 times cs, and according to that also you will get this is 2 times cos 3u into sine u. And in that case you have to assume that alpha plus beta divided by 2. So I am just going to explain this one. 2 times cos alpha plus beta, that is 6u divided by 2, that is the 3u, into sine alpha minus beta, so it is going to be 2u divided by 2, that is u, and you will get the final answer. Thank you.